Now let's look at an application of using strings. So what I want to do is write a program that will take an integer from a user that's in the interval of 1 to 999 and convert it to the equivalent words. So for example, if the user enters the number 24, then what my program should produce is the word 24. Okay? So how do we do that? Well, conceptually, one easy way would be if the user enters 1, I can do something like this, say if num equals 1, print 1, else if num equals 2, print 2, and so forth, all the way down to else if num equals 999, print 900, $99. Right, we could do that. But how many of these if statements am I going to have? Well, 1 through 999. So that means 999 of these. So is that the way we should go? Well, no. If each word was composed of units, and what I mean by that is the words, like this is 9, this is 9, this is 90, which shows up in a whole range of things, right? If they were all completely distinct, well, then I might have to do something like this. But they're not. These numbers are composed of subcategories of numbers, right? Lots of things have 1 in it. Lots of things have 20 in it. Lots of things have 900 in it. So if I can identify the base words and when to use those, I don't have to do something like this. So let's think about what we need to do. So let's write out some examples. So what do we actually have? 1 gives us 1. 2 equals 2. Work my way down. 9 equals 9. Then I have 10. 11. Work my way down. 19. 20. 21. All right, so what is this? Well, that's 20 plus 1. There's a combination. Work down. 100. Well, 1 is 100. 1, and so forth. And I can write out a lot more of these, but I'm trying to figure out, okay, what are the base units and what are the exceptions to things? So even though I didn't show it here, we would notice that everything from 20 to 29 begins with 20. And then we just append 1 through 9 to it, right? Except for 20 itself. And 31 to 39 is the word 30 plus 1 through 9, and so forth. And we're in the hundreds. It's a similar thing. So 243 is 200, and then the word 40 dash 3. The exception really is here, the teens. So that's actually the special case. Most of these other things follow a very consistent pattern, but for whatever reason, somebody decided we wouldn't say this is 10 and 10-1 and 10-2 and 10-3. They decided to give each of these their own distinctive name. So they have to be treated specially. But if I'm trying to determine, number classes, that is groups of words, I have things like 1, 2, and so forth. I have the teens, so 11, 12, so forth. We have 10, 20, 30, and so forth. And then for the hundreds, it's really this plus the word 100. So 100, 200, and so forth. So I think I have enough to start thinking about what the classes are, and I may have to fill it in. But that then leads into, well, how do you know what to do? Well, how do you know? Well, I know to use just the word 1 through 9 if there's only one digit. And I use something followed by 100 if there's 3 digits, right? Which leaves us in the middle. These are the 2-digit versions. So I need to determine how many digits I'm dealing with to narrow down what to do. All right? And then also I need to look at some things like, technically, when you write out things like 21, it's a compound word, so it's supposed to be 20-1, not 20-1 like some people write. So this is really what's correct. So when do we do these? Well, what do I have to deal with? Well, look at things like 10, there's no hyphen. 20, 30, 140, for example, 780. There's no hyphen. It's when I have something other than the beginning and a teen. Once I get to 20 and work my way up, anything that doesn't include the tens, like 114 includes the tens because it has 14. Those are the things that have the hyphens. So, 37. It's 30-7. 246 is 200. (40-6) and so forth. I'm working out examples here, try to figure out how I'm going to deal with that. Right? And then work out the logic. So this thing here is telling me that if the last digit is 0, no hyphen, and there might be some other cases, but I'll deal with that as I work it out. But I'm once again trying to figure out what the logic's going to be, because I'm going to have to ask a bunch of questions. Are we dealing with this? Are we dealing with this? Are we dealing with this? And the answers to those questions will help me narrow down what to do next. So let's look at my implementation, and then we'll come back and revisit some of these rules to better understand what's going on. So here's the classes I've identified. Let's look at this. Or let's start at the bottom and see. So here I'm going to ask the user to enter an integer with up to 3 digits. And remember that the input function over here will take whatever the user types in and enter it as a string. So even though they'll type some digit characters, it will come in as a string. So it's something like this. And we need to turn that somewhere along the way into the integer 123. So I use the int function to do that, right? And then I'm going to check, and as long as the number that they gave me is in the range of 1 to 999, I'm going to keep converting it and printing out some things. Before we look at the logic here, let's actually run the program to see how it works. So 1, 2, 3. 123. 4, just the word 4. Oops, didn't like to hit enter on there. 17, just the word 17. 999, 999. 206, 280. We can keep going. But basically what I'm doing is I'm trying to think about what are the different cases. Here's something that has a 0 at the end. Here's something that has a 0 here. Here's a boundary condition. It's at the end of my range. Here's one of the teens. Here's a single digit number. Here's just a regular number, which is kind of like this, except it's not at the boundary. Those are the type of things I'm checking. And now to stop, I can put in something like that, and it stops. So now let's look and see what the character classes are, or the number classes. So here's my basic words. 1, 2, up to 9, 11, 12. Here's the teens. Here's the tens. 10, 20, 30, 40, that kind of thing. Down here is where I'll add the word 100 to these. So when they entered 206, it's really just 2 followed by the word 100 because 2 is in the third column. Or it's a 3-digit number, I should say, right? Same thing for 280, same thing for 999, same thing for 123. So I don't need to have, 104 or something like that here. I simply just take one of these and add the word 100 to it. Right? So why have the empty strings? That's what these are. This is an empty string. Well, I'm going to do a lookup here. And when I say 1's D0, I'm going to put a number in here that's an index into this list of strings. And just to make the logic easier, I wanted the number to match the number. Meaning when you put 1's and a 1 here, you get the number 1. I could have taken out these and then put in their D0 minus 1 and still had it work. But this way I can just keep track of it a little easier. And it's not really much of a cost in terms of space or anything like that. All right? So then I come here. What does this do? This is a string operation. So what it's going to do is take that number that's passed in and it's going to rewrite it in 3 digits. That's what the 3D here is for. D is for integer, and 3 means there's 3 digits. But if the number itself has less than 3 digits, pad on the left with zeros. So what that means is, if I come in with the number 4, it's going to change it to this, the string 004. And if it was 38, it's going to change it in the string 038. And if it's 209, then it's just 209. And the reason for this is then it's easy to look at this and figure out where it's at. If it starts with a 0, it can't be in the hundreds. If it has 2 zeros, it has to be in the ones. That type of thing. So it makes it easy to do. All right? So then I want to extract the individual components of that and convert those to ints because each one will be a character. Although technically this is going to treat it as a string. So snum0 will be the first digit. D1 is the second digit. D2 is the third digit as ints. snum0 will just be that character. snum1 will be that character, and so forth. And now I'm going to ask some questions. If D0, which is the leftmost digit, if that's not equal to 0, then we have something in the hundreds. So I want to write word equals and whatever the digit is. So if it was 206, I'm going to take the 2 and write 200. Because ultimately, word is what I'm going to print or return to be printed. I return word right here, and here's where I print it. So I start building from it, and I slowly add to the end. So here's what I'm saying. If I have 237, then I'm going to start off by having 200. And then I need to add to this the word 30. Add to that a hyphen, and add to that 7. So 200 plus this will be 230, plus this will be 230 dash, or hyphen technically, plus this 237 would give me the full string. All right, so that's what this does. Now I'm trying to figure out if a dash goes here or not. So what is my rule here? I say if D1 is not equal to 0 and D2 is not equal to 0, then we use a hyphen. Right? Let's look at some examples to see what that would mean. Right? D1 not equal to 0 and D2 not equal to 0, use a hyphen. Well, what if D1 is equal to 0? Well, they have numbers like this. It's either something that was 0, 0, 5, for example, or something in the hundreds, right? 208, 300, or whatever. I'll never have a 0 in this position because we're looking at this column. In this position, if it's in the teens or the 20s or 30s or whatever, right? Because I would have something else. So that's what we get from this. What does this produce? Well, if D2 is equal to 0, then I get things like 10, 20, 140, 780, things like that. So if it's not one of these or not one of these, then it's going to be a compound word, and I'm going to have something like 27. Because 27 is equal to this. So remember, this in terms of string terms would have been this. So D1 is not equal to 0, D2 is not equal to 0. I need to use the hyphen. So since I'm simply concatenating these, I either want to add the hyphen when necessary or add an empty string, so it essentially adds nothing. And then finally, now we'll start putting things together, because the exception to what I said here was for the teens. So if D1 is a 1, then we're talking about either 10 or something in the teens. And I'm going to check this right here to say, okay, if D1 is a 1, but the last digit here is not a 0, then it's not 10. It must be 11 or 12 or something up to 19. So this would be my final word. We're adding, something like 114, or just, if we had the empty string to begin because there was no hundreds, it might just be 14 by itself. Otherwise, I'm going to have word, which is either hundreds or empty string, plus whatever the tens value is, plus the hyphen value, plus finally the ones value. And if we have something here, if I do have a 0 at the end, then remember, for that right there, I look it up and I simply just add an empty string here. So this is used in quite a few things I had in my strings video. We talked about how these format specifiers here are formatting a string, even though I often use it inside a print statement. And I'm doing the same thing here. Of course, I'm creating a bunch of these strings. I'm concatenating strings. Here's empty strings. But ultimately, I'm putting to use here strings, and you can see the result. All right? So there's an application of strings. If you find videos like this helpful, please help me out by hitting the subscribe button or hitting the like button.